Insulated concrete forms and light frame construction. This project is intended to analyze and compare two different materials, light frame construction, pictured to the right, and insulated concrete, pictured to the left. The group will discuss different aspects from both materials, covering a broad range of topics such as the history of each material, economics, durability, energy, and environmental factors, and examples. By the end of this presentation, the viewer will have the knowledge and understanding of each material to make an informed decision whether to choose which frame is suited to the task at hand. The history of light frame wood construction originated before the Roman Empire over 2,000 years ago and is still being used today. The light frame structure was introduced in America in the 1840s in attempts to settle the American West as quick as possible. The frame was ideal due to the fact that there were plenty of softwood forests here to use for these types of frames. These frames consist of different lengths and widths of wood, an example 2x4s, 2x6s, and so on, all nailed together to create a skeleton framework to a house which will be used to apply plywood for siding, insulation to maintain temperatures in the structure, as well as areas to house electrical and plumbing fixtures. After World War II, light frame structures regained popularity for their easy assembly and relatively low costs. These frames are the standard in America today for suburban homes. Variations of insulated concrete forms first appeared after World War II. These variations consisted of treated wood fibers which would be mixed in with different types of cement. By the 1950s, chemical companies found the potential value in this material and decided to develop plastic foams, which would later pave the way for a Canadian inventor to produce a material that resembles insulated concrete forms as we know it today. In the mid-1990s, the Insulating Concrete Form Association was founded and partnered with the already established Portland Cement Association to raise awareness of this energy-efficient material. As the construction industry started to utilize this material, more manufacturing plants began to sprout up and thus drove prices for the material down, making this material a heavily favored material. According to NAHB.org, the average cost for lumber can cost anywhere from $3 to $7 depending on the market at the time. Taking this into account, a little math can give us the average cost to frame a house in America, which happens to be right around 2,500 square feet. It'll come out to equal right around $12,500 for all the wood material, not accounting for labor, and different types of wood, including treated or non-treated wood. The average framing labor per square foot can range anywhere from $2 to $12. This will add another $12,500 to the total cost of putting the framework up, giving us a grand total of $25,000. This cost is actually relatively low compared to other materials that would be used to frame a house, as we will see later in the presentation. This cost is relatively low and durable enough to make this the standard for American homes. The initial install of insulated concrete is about 10% more than other building materials, making it more expensive than light frame wood construction. Taking our previous example, instead of the framed house costing $25,000 to build, it will now take roughly $27,500 to frame the same house with insulated concrete. This initial investment, however, is minor compared to the money saved in monthly operating costs insulated concrete provides. On average, these forms have saved anywhere from 20 to 25% on monthly operating costs. The table provided by the U.S. Department of Housing and Urban Development compares the monthly pricing for standard wood home, upgraded wood home, and ICF home, making this material cost-effective regardless of the initial cost. Wood framework is not the most durable material on the market. However, it is one of the most cost-effective for what it is. Wood framework is susceptible to moisture damage from rain and condensation. This excessive moisture can lead to mold growth, which can weaken the longevity of the structure. Wood, being organic, can also attract termites and other insects, which can also weaken the structure. This frame is, however, durable enough to support numerous floors being added to the structure. With this being said, it's also more prone to the wind, which could possibly vibrate the framework enough to bring the structure to the ground. Insulated concrete is far more superior than wood framing when it comes to durability. Insulated concrete has very strong and rigid walls, which helps it resist natural disasters such as hurricanes, tornadoes, and hail. Another plus to this material is its resistance to mold and insects. Unlike wood, insulated concrete is not an organic material, which makes it the ideal material to be used in moist areas as well as bug-infested. The tables provided by the U.S. Department of Housing and Urban Development show different tests including racking strength, comparison of bending, comparison strength, and wind-borne debris impact. Energy and environmental problems are some leading concerns today in America. Insulated concrete forms are far more energy efficient than wood frame structures. Most ICF structures can see anywhere from 20 to 25% savings per month in energy bills. To achieve this for wood frame structures, one would need to invest $1.35 per square foot in order to compare to ICF. By taking our example from earlier, we would need to invest another $3,375 into the 2,500 square foot house. The graph pictured here shows heat flow through the roof system during the winter time. On the left we have wood, and on the right we have ICF. And here we have another heat flow through the roof system during the summertime. Again, on the left we have the wood structure, and on the right we have the ICF. There are many light-framed wood structures all over America. Here's an example fairly close to home. On 43rd Street, next to ODU's main campus, we see a light-frame construction being used in two-story townhomes. The foundations have already been poured with concrete. The floor joists are already installed. These floor joists will then have subflooring attached in 4x8 panels. Next, they will add 2x4 wall studs which will hold the insulation, wires, and plumbing for the house. It will also hold the roof rafters for later in the project when the roof is ready to be assembled. Here we see an example of an ICF custom-built home that is over 11,000 square feet. This home was built by a local building company called Meadow Green Builders, whose goal is to build homes that are both energy efficient as well as durable. This is just one example of their homes they have built. These homes that use insulated concrete forms are ideal for areas like Virginia Beach, Suffolk, Chesapeake, and Norfolk because of the wet weather experienced here. Traditional homes that use wooden frames are more subjected to moisture damage, with occasional floods experienced here in the low tidewater region. This material also performs well, as we have seen earlier, in hurricanes and tropical storms, which are not uncommon for this region. Meadow Green Builders have been working with ICF for over 18 years and can build ICF homes starting from $150,000 upwards. In conclusion, based off the table pictured, it seems insulated concrete has won most durable. Wood just doesn't compare with the fact that it is prone to moisture damage and natural disasters. When it comes to cost, wood framework does have a slight edge over insulated concrete. It is more cost effective to frame a house using wood than it is with ICF. Hands down, energy and environmental goes to insulated concrete forms. With the money saved in heating and insulation bills each month, it seems it would be worth putting this durable and energy efficient material in. Both of these materials have great qualities, which could be the reason why both materials are still heavily used today. In the end, it is up to the contractor that decides what will be the most effective material to use based